Hey y'all. Okay, so we are going to do some inverse functions. You could also hear these being called opposite functions. If a problem asks you to show that f of x equals 3x plus 2 and g of x equals x minus 2 over 3 are inverses. So we're going to show inverses. Okay, so what you do is if you can plug g of x into f of x and get x for your answer, and also plug f of x into g of x and get x for your answer, then it means that they are inverses of each other. So firstly, what we're going to do is plug g of x into f of x. So we would have f of g of x. This is literally, I've got to hold this pen differently. This is literally plugging my g of x function into my f of x function. So what this would be f of, now instead of x, what you would do is plug in g of x, which if you look at g of x, I've got x minus 2 over 3. So now I look at my f of x function. So if you notice up top, I have f of x equals 3x plus 2. But what I'm doing right here is f of x minus 2 divided by 3. So what that's saying is that wherever you see an x, it's now going to be this fraction. So what we have is 3, there's an x, so this is where my fraction goes. And then my function had a positive 2 at the end. Okay, so, if it lets me, barely, literally didn't do anything. Okay, so what we're going to do here is notice that this 3 can be written over 1, right? So technically it's in the numerator. And if you have something in the numerator and you have something in the denominator, you can cancel them. So these would cancel. And what I'm left with is just x minus 2 plus 2. Okay, so my negative 2 and my positive 2, those are additive inverses. And what I mean by that is when you add them together, you get 0. In other words, they go away, right? They cancel. So what I get is x. Now, if I can plug my f of x into my g of x and get the exact same answer of x, then these are inverses of each other. Okay, so my g of f of x. So what I do is I look at my g of x function. It won't let me go up. Oy vey. I look at my g of x function, which is x minus 2 over 3. And I'm so irritating. So now, y'all, wherever you see an x, we're actually plugging in this, because now we're plugging in our f of x into our g of x. So in the numerator, I have 3x plus 2. Look at your g of x. I had negative 2 over 3. Oh, finally. Okay. So I'm going to go. I'm gonna lose my mind. That's what is gonna happen. I'm gonna lose my mind. Okay, so I noticed that those parentheses are actually not really necessary for this particular problem, because there's nothing touching the parenthesis. It's nothing. It's going to be distributed. There's no multiplication. So just for clarity and to kind of see it, what I'm going to do is just write it without the parentheses. Okay, so hopefully it looks a little bit more clear that those are additive inverses. They go away. What I have is 3x over 3. That right there is actually a multiplicative inverse, but let's just, for the sake of this problem, 3 divided by 3, that equals 1, right? So what I get is x. They both equal to x when I plug them into each other. So yes, they're inverses. Okay. Now I want to do a problem real quick for this video. They actually gave me 2 functions and they asked me to show that they were inverses. So I knew I could plug them into each other. And if both of them got x as an answer, then that means they are each other's inverses. Now, what if I'm not given 2 functions and told to see if they're inverses, but instead I'm just told to find the inverse of a function? So if I'm going to find the inverse, what you do is literally where you see a y, it becomes an x. Where you see an x, it becomes a y. We're going to switch them. Technically, you're just rewriting the problem. And then the next step is to solve for y. So this is meaning to get the final answer in a y equals format, okay? And that will be your inverse. So if we have y equals 7x and a minus 5, a negative 5. So applying the very first step, right, it told me to switch. So now it's x equals 7y minus 5. Now, step 2 tells me to solve for y. Well, if I'm going to solve for y, I need it to be y equals. Right now it's x equals, so it's all jumbled up, right? I need to get my y on the left-hand side for it to be y equals. I notice that I've got a 7 multiplying it, and I have a 5 being subtracted from it. When I'm solving a little equation like this, what I want to do is whatever is the easiest mathematically to do first. And what I mean by that is the 7's multiplying the y. In order to undo that, I would need to use the inverse, which would be division, right? But if you look at that 5 right next to it, it's being subtracted away from my y. The inverse of subtraction is addition. So if my 2 options are division and addition, mathematically, which one's easier? Exactly, addition. And what you do to one side, you have to do to the other. X plus 5, they are not like terms. It is literally just x plus 5 equals, those canceled, I get a 7y, right? Now I look, and the only thing that's keeping me from having a y equals is that 7. I know I said a minute ago I needed to get it to the left-hand side. I'm used to getting it on the left-hand side. In all honesty, as long as you only have the one single variable that you're solving for, it doesn't really matter what side it's on, okay? So here, it does matter that it's being multiplied by 7. I need to actually get rid of that 7. So what I do is the inverse of multiplication, which is division. And on the left-hand side, I get x plus 5 over 7 equals, those canceled. I just have y, right? So I solved it. Even though it is on the right-hand side, this is still y equals x plus 5 over 7. So that means that this is the inverse, okay? So that's my inverse. And there's an actual notation that we use, which is like a script f with a -1 as an exponent. And then you have your x inside of parentheses. That is saying the inverse of f, or f inverse, either way. Okay, awesome. Thanks, y'all. If you have questions, make sure you let me know.